So it asks that f is a following function defined as follows. F of n, okay, sounds good. If you compute this value, this looks pretty straightforward, that if to define compute this value, but the function is over like -5 to 6, so that's kind of computational in nature. So this kind of tells you that, number one, that so when you see this problem, what do? Naturally, you write down, like it's an algebraic format, like a lot of numbers. So when it's normal lot of numbers, you write down the numbers properly. Okay, you write down the generalized form. So let me write down the generalized form for you. It's -5 to 5 and 6. So what? Let's do this. Let's try to calculate a few of them, the easiest one. So f of 1, and let's see if there is any pattern or not. So f of 0, let's say. So f of 0 is, you can see, 1 by 3 to the power 0 plus root n. Sounds good. F of 1 is, so the goal is to find any pattern, okay? 3 to the power 1 plus root 3. F of 2 is, f of -1 is 1 by 3 to the power -1 plus root 3. So let's calculate this and let's see if we can find any pattern. So you see, the step number 1 is to make the problem easier. So to make the problem easier, we are finding out smaller values of f1 and see if we find any pattern or not. Okay, because everywhere there is pattern. So let's see. 3 to the power -1. So we can just do 1 plus 3 root 3, and then 3 comes here, right? So can we find any pattern from here? Let's see. Um, can we connect these two? Because you see, the basic idea of symmetry, like if this is a non-computational, like there could two kind of problems, right? Where you have to really compute hard, and then get it. And one is like you have to understand some pattern, look into some pattern, and you will simplify things. All the entrance examinations are based on this mostly, to simplify things so that you can easily understand them. IIT JAM MS to extent is not that, but IS and CMI 100% is that. So to simplify things, we simplified to, instead of -5 to 5 and 6, we simplified to -1, 0, and 1, this region. And we're trying to understand if there is really any pattern out there. Okay, so let's see. So this is 1 plus 1 root 3. So now if we take root 3 common, it will turn out to be again 1 plus 1 root 3. But here there is no common stuff out there, right? Um, so can we connect somehow um, this to any other things? That's the main question. It seems like, let's when you are out of, when you cannot really think, you try to find out, like write it down clearly. 1 plus root 3, f1 is plus root 3 plus root 3, f minus 1 is 1 plus sorry, 3 by 1 plus 3 root 3. Okay, so let's calculate. One interesting thing you must see is that uh, here it's -5 and 6. So that what it's saying to my mind is that, like, why it's not -5 to 5 and why it's 6, is any other relationship out there. So let's do, so what we'll do is, now we will do -1, 0, 1, and 2. That's an easy generalization of this, right? So we will try to do that. So let's do f of 2. So f of 2 is 1 by 3 square plus root 3. Is it true? Yes. So, okay, this sounds interesting, and I think I have understood it. It's this. If you observe, it's 3 square means 3 root 3 plus 1. So you can see that -1 and 2 has this relationship. And here, if you see that root 3 into 1 plus root 3 has this relationship. Do you see the relationship? guys, that this part is common, and here this part is common. Yes or no? Let's try to see it for three in general. We will do, so it's 2n minus 1, 0 and 1. We will get 3n minus 2 probably. Or, yeah, let's see 3n minus 2. F of 3 is 1 by 3 cube plus root 3, and f of minus 2 is 1 by 3 to the power minus, so 1 by, so 3 square here plus 3 square root 3, which is yes. So of course this is true. So it's 3 square root 3 plus 1, and here 3 square by 1 plus 3 square root 3. So do you see the relationship between f of minus n and f of n plus 1? What is the relationship? Let's write it down. So you can see the relationship again here, right? I hope you can see that the same relationship holds. So somehow, so you see the point, that how did I understand that there may be relationship between this? I just spoke it out loud, right? Because of the asymmetry of the equation. So why it's f of 6 and f of minus 5? So we are looking at the asymmetry of the equation. We are trying to understand the asymmetry. Uh, so now let's generalize it, right? Generalization in the sense that f of minus n and f of n plus 1. So the important part to note here is not getting the solution, okay? Because this exact problem will not come again, but is to understand the approach, how I am thinking from the very fundamentals. We are going to the fundamentals. We try to make the problem simpler, and then make questions like, why is asymmetry? How to make the problem simpler? That's how to solve it in a simple manner. It's the main question that you should always ask. The only question you should ask is how to make the problem simpler, how to solve the problem in a simple way. So here, if you see, it's 3 to the power minus n, so it turns out to be 3 to the power n, 1 plus 3 to the power n root 3, and here it is 1 by, if you observe, root 3 times 3 to the power n root 3, because it's root 3, will make it 3 to the power n plus 1, and plus 1 times root 3, which gives this, right? So therefore, you can see that you can find a relationship, f of n plus 1 divided by f of minus n is, or you can do the other way around, f of minus n by f of n plus 1 is, this gets cancelled, so 3 to the power n plus half, right? Root 3 gets to the top, right? So this is the beautiful relationship that we have got. So we get paired by 0, 1, minus 1, 2, right? Um, minus 2, 3, minus 4, 3, 4, minus 4, 5, minus 5, 6. So we have this 12 numbers out there. Got it, right? Perfect. So now let's see how we can again simplify it. So we have summation of k from 0 to minus 6. You can see how I'm writing down the equations step by step. By simplifying it, write the arithmetic, then you will only get the algebra. So 0 to 6, minus 6, 0, 1, 2. Everything is now f of minus k and plus f of k plus 1. This is how we can write it. Great. minus 5, sorry. So, okay, this is what we have got. Now let's see if we can find it in a better way. Um, so this, we know this is true. So what we will do is that we will write everything in terms of f of k plus 1. So f of minus k will be 3 to the power that time. So it's 3 to the power n plus half plus 1 times f of k plus 1. Got it? Right. This is what we have got, right? F of n plus half time plus 1, because this f of minus k is equal to 3 to the power n plus half. It will be k, f of k plus 1. So we just replaced it. Let me just see if it's fine or not. Yeah, this looks good. Now, this the next step is naturally to expand this, because to utilize the idea of this. So let's expand that. What is f of k plus 1? So this is again summation. I'm not writing the indices. So summation 3 to the power k plus half plus 1. F of k plus 1 is, let's replace it. I think. So 1 by 3 to the power k plus 1. The good thing is that you will get back the same thing. Root 3 common, you will get back the same thing. Okay. Root 3 is common, you will get back the same thing. Yes, if you put it. So this will get cancelled out, and you get minus 1 by root 3. And then you have this root 3 out here in the beginning. So this root 3 get cancelled. So it's nothing but summation from k to 0 to minus 5. So 0 to minus 5 is there 6 of them. So it's 6 sums of 1. All of you understood it? How to simplify things? Every single step by step.